Welcome to PowerShift, where we explore the bold ideas and leaders driving the future of energy. Today, we have the honor of speaking with Craig Barrett, former CEO and chairman of Intel, a pioneer in semiconductors, advanced materials, and high-tech innovation. Welcome, Craig, to PowerShift. Maybe you want to give us a little bit introduction about yourself for the audience?
First of all, Ghazal, thank you for having me, and it's fun to talk about this subject. It's quite a bit different than semiconductors. I mean, I've spent my life making things super small and getting power for the world, sustainable baseload power. It's a super big job, so it's kind of a dimensional change.
I would like a little bit deep dive on that you spent decades on leading Intel and that high-tech technological challenges that you resolved. So what do you think in terms of the material science and the breakthroughs that we can bring to energy system, especially for geothermal, because we know that we need heat, because you mentioned about heat beneath our feet. When we go hotter and deeper, high temperature has some challenges that on accessing to this hot rock.
I mean, if you get hot rocks right on the surface, if you go to Iceland, you go to New Zealand, you see geothermal everywhere. All you need to do is have some water and pour it on the surface hot rocks and get steam, and you're okay. It's a little bit more of a challenge in the rest of the world where you have to drill, a mile or thousands of feet down to get hot rocks. And it's a little bit like your home. When you have a home in Montana, it gets hot in the summer, it gets cold in the winter. I try to insulate my house from the outside because the thermal loss is just a conductive loss out windows and out walls. Collecting heat is a thermal issue, and what you want to do is have very effective heat transfer, first of all. And so you need to worry about sticking a pipe down, getting good heat transfer to that, and there's an interface between the rock surface and the pipe surface, and you need to do the opposite of what I do in my house. I want great thermal conductivity from the surrounding rock to the pipe, and not poor thermal conductivity like I have in my house. So that's a great materials problem. It's a problem to get down there because it's hot rock that you have to drill through, so drill bits and there's great drill technology that's happened. That's all a materials problem. I mean, you need a super hard surface to grind through rock, and you need wear resistant. You need data information about the nature of the rock you're drilling through. You need sensors in the drill bit to monitor temperature, pressure. You need all sorts of cool stuff, all materials problems. So material science, is pretty much everywhere around you on everything, whether you're doing atomic engineering to make transistors or you're drilling a 5,000-foot hole through solid granite. It's all materials problem.
You mentioned about Iceland and New Zealand. I know you love to go there and you spend time there. But most of the people, when we talk about geothermal, they think about the volcanic, hot reservoir water. So how do you think this innovation in material science in terms of heat transfer technologies, next generation of geothermal that really relax the constraint from the subsurface water and geology, like what we do at XGS, bring geothermal like a forefront of development globally? So we are not just looking at the specific geographic.
This is a real challenge. It's obvious if you're in a volcanic region like Iceland or New Zealand that it's easy. You've got a lot of water. You just pour it on the hot rocks, and you get steam, and you got energy. It's a little bit more of a challenge around the rest of the world, where you have to drill a deep hole and then have all this thermal conductivity stuff. And you need to convince people that it's doable. Years ago, I chaired the advisory committee on the Berkeley National Lab, the Department of Energy facility. They were concerned there about alternate energy sources to hydrocarbons. And I used to talk to them about geothermal, and their eyes would glaze over and say, well, if you're in Iceland, it's great. But if you're in California, other than a few spots in California, there are no geysers. And they don't think about geothermal. And correspondingly, they were at that time not interested in it at all. Fortunately, by happenstance, we have a president now who his favorite comment is, "Drill, baby, drill." And President Trump, unknowingly, is really promoting geothermal activity. He wants to drill for liquid gold, and that's oil or gas. There's another liquid gold down there, it's heat. But finally, people are recognizing geothermal is an infinite source of energy, and clean, and 24/7, in a small surface footprint. It's everything that everybody wants, but just nobody's thought about it.
So basically, you mentioned three topics. It's reliable, affordable, sustainable. And with the next generation technology, that really reduce the upfront risk and cost and make it more financeable, and also remove the geographical constraint, which is where we're talking about the hydrothermal is mainly in the certain geographies that geology and the water exists. We can really tap into this source of energy anywhere.
Drill, baby, drill.
Awesome. So, Craig, let's talk about investment. You invested at XGS. You are one part of the investor committee, and then also you believe in this source of energy. So, can you walk us through that? How did you come up to this field from Intel to energy, renewable energy domain, and why next generation geothermal?
Well, first of all, there are certain industries that use a lot of power. Semiconductor industry, manufacturing, use a lot of power, a lot of high temperature treatment, things like that. So very cognizant about power. But if you think a little bit broader than that, you'd like to have a power system or power generating capability which is not really geographically dependent, that you can do just about anywhere, so that you don't have to worry about massive transmission characteristics, big footprints that spoil the environment. Like I drive through California and Nevada, I see these huge solar farms, and they're not exactly my idea of the great outdoors. It's kind of mankind infringing on the great outdoors. But I just got interested in the simplicity and the elegance of geothermal. I mean, if you think about it, you don't have to burn anything. You don't have to spoil thousands of acres of the environment. You get no emissions. It's a 24/7 clean system. By the way, Montana's got a lot of hot rocks. Yeah. It'd be very easy to do that there. But it'd be very easy to do nuclear there. But it's the elegance of this. And it doesn't face the kind of public reaction that nuclear has. So, 10 years ago, I ran into one of our board members, the founding board member, Piot, and he was describing this to me. I said, it's a pretty cool idea, and it's elegant, and it's got a lot of materials problems, so I was interested in it. And I've been bouncing around with this idea. When I was on the advisory committee at Berkeley National Lab, energy was the big topic there, and I used to try to get them interested in it, but they were kind of set in their ways and looking at current sources and not potential sources.
Along those lines, I think tech companies like Intel, Google, Microsoft, Amazon, they are the biggest energy consumers, right? Do you think that this type of resource of energy is going part of their energy strategy? So do you think that they need to co-locate geothermal power plant for their data centers, for heating, cooling, security? What is your thought about that?
It's an interesting issue, which companies like Intel have fostered on the world, which is these data centers. And with the AI coming into play now, huge data centers and huge power consumption. And most of these folks are very environmentally conscious, and They want to use green energy, if possible, and they want to locate these places where there's cheap energy, because energy is one of the biggest costs of the data center. Something like geothermal is phenomenal for them, because you don't have to worry about new expensive transmission lines and that sort of infrastructure. All you need to do is drill, bring up some hot water, and you have a local power situation, which is 24/7 and on demand, and it's inexpensive. I mean, it's perfect.
What not to love about?
It's what, yeah. And in fact, they're all interested in this and thinking about it, because the energy situation is the key situation.
I love when you say all the time, geothermal is elegant.
Geothermal is elegant because it is so simple, and simple things last. And they don't have added complications. Collecting the heat that comes out of the earth is simple and elegant.
We love it.
I love it.
So you have spent your career working the cutting edge of the technology, as we mentioned. So if you want to work on something very exciting and it's not a part of the energy industry, what do you work at?
Well, I have two things that come to mind. I mean, one is I've lived through the vacuum tube to transistor transition. And we're still, after 60 years, we're still following Moore's Law. You know, when I joined the semiconductor industry, the biggest chips at that time had maybe 250 or 1,000 transistors. Today, the chips have maybe 100 billion transistors. That's Moore's Law. Mm-hmm. And that has been so exciting. Nothing doubles every year or two for 60 years. I mean, it doesn't happen. But the exciting thing that I would, if I was a young engineer and just getting going, that I'd like to work on is Moore's Law won't last forever. It's still going. It's still got another 10 or 20 years. And every time we say it has 10 or 20 years, we get a lot of bright engineers working on it, and it lasts another 10 or 20 years. But I'd like to work on the replacement for the CMOS transistor.
Okay.
You know, transistors are made out of atoms, so you're doing atomic engineering. The next level down is kind of quantum computing. An electron spin, a lot smaller than an atom. If that is the electronic switch of the future in various instantiations, but if that's the electronic switch of the future, I'd love to be part of that. The other one is, the reason I go to New Zealand all the time is I'm a fly fisherman. And, you know, the technology of fly rods, these very light things that bend and cast the line, you know, it's a fiber technology. Bamboo was the first material. Then it was fiberglass, the second material. And then it was graphite fibers. And what you're doing here is getting stiffer fibers in a matrix of some sort to make these things lighter and more flexible. And then it's boron fibers, which has a better modulus of elasticity than graphite for this. I'd like to work on the next generation of fly rods.
That's exciting.
And you know, it's not a huge market, but if you're an avid fly fisherman, man, you may put a lot of importance on the quality of that fly rod in your hand.
Yeah, this is fascinating. Your material science background and how you apply it in terms of efficiency increased through from your hobby and to your interest. That really fascinating.
Well, it's kind of an offshoot, but it is a hobby of mine.
That's great. So I know that Craig, you are really pushing for STEM and education, and this is very close to your heart. Do you have any recommendation or suggestion to younger generation that they are seeking to be part of this journey? They were asking, okay, is geothermal is the right segment? So what is your thought on that?
I talk to a lot of young people starting their education and wondering what they should major in, and if they're engineers, what they should do. And the first bit of advice I give to people is, if you study engineering, and engineering is really a profession of problem solving. And if you learn problem solving skills, you can apply them anywhere. And there's a good reason why the most common education background of Fortune 500 CEOs is engineering. Mm-hmm. It's not business school, it's not law school, it's engineering. Because running a big company is problem solving, all different types of problems, not just technical problems, but people problems, marketing problems, manufacturing problems. So I really am an advocate of engineering education. The second one is, by golly, you can't look at any area that doesn't have materials problems in it. Geothermal has got a bunch of really interesting problems. Semiconductors got a bunch of really interesting problems. The marriage of biology and engineering, the biosciences and bioengineering, huge opportunities. So the issue, though, is you have to get the background to start with.
Fundamental matters.
The fundamental matters. And, one of my sideline activities is running charter schools, alternative to the standard public K-12 education. But we give kids a really heavy dose of math and science in our schools, and preparing them to go to the university, then preparing them to go out into society. Absolutely. But the engineering problem-solving skills are just critical, and especially as the world becomes more complex.
Thank you, Craig. This has an incredible discussion, and you really helped in a lot of segment to shape the technology and make it basically possible. So we are very fortunate to have you to really work on the future of the clean energy with us. So thank you so much for being here today at PowerShift. Any final thoughts?
Drill, baby, drill.
Drill, baby, drill. So great. So thanks for your insight. And back to our audience, please stay tuned. We come with more very exciting discussion with the leaders in industry to shape our future of the clean energy. See you next time.